Okay, hello everyone, welcome to the new week. In the last week, we have introduced the materials for the relational algebra already. If you still remember, in that section, we introduced many different operations we can use for querying the relations. At the very beginning, we introduced the motivations first, and then we talk about some basic operations, like the set operations for the union and difference, as well as some other basic operations like the selection, projection, product, as well as the renaming, right? And based on this basic operation, we can further derive some more complex operations. We introduce both the set operation and complement as well as the intersection, and we also mainly focus on introducing several different joins, right? I really hope you can follow the materials we cover in the lectures and can also understand what does it mean, right? By using this operation, we can query the relations and to get the data we need. So I received some emails from students asking questions for the materials. Generally, I'm open to questions, but I have a suggestion for you, right? So do please follow the lectures we schedule for each class. I mean, some students watch the lectures very late. I mean, they don't watch the video like 4 weeks and then watch all the video at one time. It can be a problem for you, right? Because it is hard to digest so many diverse materials at once. It's very hard even for me. So therefore, you may have not so unclear confusions or questions. It should be very easy to understand if you follow the materials or lectures in each class. So do please watch the videos in each class. Don't accumulate these videos and watch them at once. It's very hard. It's not a good option for you to learn the materials. Okay, I still want to clarify some of the questions I received from the students. Even though I think some questions should be very easy if you follow the materials and lectures we cover in class. So the first question is on the renaming. In the last lecture, we have introduced the renaming about some relations into new relations, right? Renaming means given a existing relation like the employee, right? We have both the relation name as well as attribute name, and we want to rename this existing relation into a new one, right? We can use the role to denote the renaming, right? In the last lecture, we show an example for renaming an existing employee relation into a new one. We don't change the relation name, but only change the attribute name, right? We can use the role to help us to do the renaming by the role with subscript, social security number, first name, right? These are new attribute names, and we were working on an existing relation, the employee. So by using this operation, we can rename this existing relation employee into a new employee relation. And we change the SSN to social security number. We change the name to the first name. So this is the example we show in the lectures. And I also received a question from students asking if we also want to change the name of the relation. How will we do this? Actually, in the lecture, we have provided the answer already, right? If you still remember for renaming, let me go to the slides for renaming, right? For renaming, we provide as a role and the subscript SB1 to BN, right? This SB1 to BN denotes a new relation we want to rename, right? This R is an existing relation. By using this notation, we can rename the R relation into a new one, right? S is a new name, B1 to BN to be the new attribute names. So by following this notation, we can represent the renaming if we plan to change both the relation name as well as the attribute name. We can use the notation role provide a new relation name, the workers. Is a new name for the relation, for example. And we'll change the attribute name from SSN to social security number, from name to the first name, and we are working on the employee relation, right? So by using this notation, we will be able to rename the employee relation into the workers, right? We change both the relation name from employee to workers, and also change the attribute name from SSN to social security number and change name to first name. So this is the notation we can use, right, to change both the relation name and attribute name we provide in the lecture. And sometimes we don't want to change the relation name, we only want to change the attribute name. We can do so by using this notation as shown here, right? So this is for renaming. I also received a question for the theta join. They ask for the attribute if we need to delete some attributes or not. So let me go over the example again, right? We have two relations. The first one is the bar. The bar has two attributes. The first one is the bar name. The second one is the bar address. We have another relation, the sales. We have three attributes: bar name, beer name, and the price, right? And we want to do a theta join between the bar and the sales. Based on the theta, the condition is bar.name equals to sales.bar, right? Which is assumed here. We want to do the theta join between sales and the bar, right? The condition we provide is sales.bar equals to bar.name. So we provide the solution for this theta join as shown in this table, right? We can create a new table. This table has 5 attributes: bar from here, right? Beer from beer here, price from the sales table price, and we have a name from bar, this relation, as well as address from this address as shown here, right? We combine all the attributes we have in these two relations into a new one, and we also combine all the tuples we have and check if the bar.name equals to a sales.bar or not. If so, then we can keep them in the result, right? I received an email from a student asking if we need to delete either the bar or the name or not. The answer is no, right? Because in the lecture we have provided how to derive this theta join already, right? So you need to know how to derive this theta join based on the basic operation we have covered. If you still remember, we introduced the theta join can be derived by using both the product with selection, right? The theta join between sales and the bar based on this condition equals to selection sales.bar equals to bar.name, and we're working on the product between sales and the bar, right? So to understand the physical meaning of a theta join, you don't need to memorize how to calculate this, right? You need to know how to derive this theta join, this operation, based on the basic operation, right? If you can understand what this means, this basic operation means, then you should be able to know what we are doing for theta join, right? We'll provide an example how to derive this theta join in the previous lectures. You can go over the lectures again and to check if you can follow the materials or not. So we calculate the product between sales and the bar first, and then further apply the selection to select some tuples, right? So please do check the basic operation first. What does this product mean? What does this selection mean? Then you should be able to understand the physical meanings of this theta join and should have no question on these attributes, right? So this is about theta join. We keep all the attributes from these two tables because we calculate the product first, right? We have 5 attributes. We don't delete any attributes for the theta join, right? So this should be a very easy question. And from the same email, the student also asked the difference among theta join, equijoin, and natural join. So to answer this question, you also need to derive these joins based on the basic operation, right? We have introduced that theta join equals to what? Equals to the selection. The theta is a condition, right? And we're working on the R1 times R2, right? So in other words, the theta join between R1 and R2 equals to the selection theta, and in the parentheses we have R1 and R2. If you know what does this mean, then you should be able to know the physical meaning of the theta join between the R1 and R2 relations, right? We calculate the product first and further apply the selection to select some rows. So this is theta join. For the theta join, we have 2 inputs, R1 and R2. And we also need to specify the condition for the theta, right? This theta is a condition. And this condition should be further used in the selection, right? This is a condition here. So we specify the conditions for the joins, right? And this theta condition can be any condition. We can use equalities, we can use less than, larger than, we can even apply the not, and, or to derive some complex conditions, right? And for the columns, we have no definition of the columns. This column denotes attributes, right? Because theta join, we don't delete any attributes. We keep all the attributes from R1 and R2 in the final table, right? So we have no deletion for the columns in the theta join, right? Then how about the equal join? We mentioned equal join is a special type of theta join, right? You can check the format between theta join and equal join. They're the same almost. The main difference is we change the theta here, its condition here. We change the theta condition into A equals to B, right? A is the attribute from R1, B is the attribute from R2, right? So therefore, based on theta join, we should be able to derive how to represent the equal join between R1 and R2, right? It equals to what? It equals to selection R1 dot A equals to R2 dot B, and we're working on R1 times R2, right? So if you can understand the theta join, there should be no problem for you to understand the equal join, right? It is also a special type of theta join. The main difference is we change the general theta condition to the equality condition, A equals to B, in the equal join. So therefore, for the equal join, we have two inputs, R1 and R2. They can be any relations, and we have a condition. However, different from theta join, the condition here we use can only be the equalities between two relations, right? Only equalities. And it is also a clearly specified condition in the equal join. And similar to the theta join, we have no deletion of the columns. We keep all the attributes from R1 and R2 in the result for the equal join, right? So this is the equal join. Then how about the natural join? We provide example in the previous lecture, right, about natural join. For natural join, we clarify that they don't provide any conditions at all. We have no condition for the natural join, right? It is just the R1 joins R2. If we have no condition here, then this one denotes a natural join between R1 and R2. Because we have no condition, therefore for the natural join, we have to find the join attributes by this operation automatically, right? And we have two inputs, R1 and R2. Normally we have an assumption R1 and R2 can share some common attributes. I mean, they share the same attributes between R1 and R2, right? The same, I mean, they share the same name as well as the value type for the attributes. So by comparing all the attributes from R1 and R2, this operation will automatically find the join attributes. I mean, the shared attributes between them, right? And they do the joins based on the shared attributes. Then you also need to know how to derive this natural join based on product, selection, and projection. Inside this operation, we first calculate the product between R1 and R2, right? We still do this. Calculate the product between R1 and R2. Then we further do the selection with the join attributes. I mean the shared attributes. The R1 dot shared attributes should be equal to R2 dot the shared attributes, right? Then we can use the selection to help us to prune some rows in the result, right? However, the main difference here compared with the previous two only have the selection. However, for the natural join, we will do one further step. It is called projection, right? Because we will only keep one copy of the shared attributes. We combine all the attributes from R1 and R2. However, we have some duplicated attributes. Therefore, we have to use all the attributes minus the shared attributes. We only keep one copy of these join attributes in the final result, right? So you need to derive this natural join by yourself on your paper. It equals to what? Equals to the projection of all attributes minus the join attributes. This notation denotes we only keep one copy of the join attributes in the final result, right? And inside it, we further have the selection based on the join attributes, and we are working on R1 times R2. So if you can derive this basic operation, this expression, you should be able to know the physical meaning of the natural join, right? And we are still working on two relations, R1 and R2, and we have an assumption R1 and R2 can share some common attributes. For this natural join, we have no clearly specified conditions. They join based on some common attributes, and we name these common attributes as join attributes in the slides, right? And another difference compared with the previous two joins, for the natural join, they will delete the duplicated columns with the same attribute name. We achieve this deletion based on the projection, right? By the projecting all the attributes minus the duplicated join attributes, we should be able to get all the attributes and also keep only one copy of the same attributes, of the shared attributes, right? So to compare the difference among these joins, do please derive their representations based on the basic operations. Please derive this theta join with selection combined with the product. Derive the equal join with selection combined with the product, and also derive the natural join by using this projection, selection, and product. And you can further check the examples we provide in the lectures and the slides. You should be able to know the difference among them, right? And if you still have a question for these joins, do please derive them by yourself on your paper, and you can further to design some examples by yourself and to calculate the join results by yourself on your paper. Then you should be able to understand their difference. Of course, you also need to know the physical meanings of the basic operation, right? The product, the selection, and the projection. We have provided this already. We will not go over again for you, right? So you need to work on this by yourself to understand the physical meanings of these basic operations, and then further derive them on your paper for the joins. And then you should have no problem in understanding the joins as well as the difference. So this is a question I received from students asking for the relational algebra. So I have a suggestion. So do please work on this lecture and the slides on time. Please don't accumulate all the videos and watch them at once. It's very hard for you to follow the materials. In this way, you will have lots of problems, and this problem should be very easy to resolve if you watch the videos on time. Okay, so this is a suggestion for you, right, for the previous section on the relational algebra. In this week, we will move to the new section on the relational design. This section is more difficult than the previous section, so do please work on this course as well as the lectures on time. It will be helpful for you, right? Okay, so let's go to the new section on relational design.